Hi everyone, today I'll be showing you how to use SPSS Statistics 20 to run a Pearson's R correlational test. There are a few things to note before running this test. For example, the variables that you are using. In this situation I'm using height in centimeters and mass in kg. You need to assume that there is an association between these two variables and not a difference, because that would be a difference test. You also need to assume that they are on an interval/ratio scale, as you can see here on the measure. We know that height and mass are both on the scale because there is a true 0 point, or the numbers between each other can be quantified. If we switch to the data view, I've also coded my participants, so if you need to see them later because there's an outlier or something that you don't like or do like, you can draw out which participant is affecting the results. So I've got height and mass in one column. To move forward to the Pearson's R correlational test, there are a few assumptions that need to be brought out. You need to know that there are two variables, which is height and mass in this case, but if there are any more than two variables, you might need to suggest doing a different test, for example a multiple regression, if you're looking at relationships still. You also need to know if they're interval/ratio, like I've already said. But you also need to know if they're normally distributed, so if they have normality between the participants. To do this, you go on Analyze, you go on to Descriptive Statistics, Explore, and you move both the variables in the dependent list. So you just press this arrow here to move it back out, and arrow to move it back in. You go on to Plots here, and make sure that Normality plots with tests is checked. You can also check in a histogram if you want to see it in a graph view, but we won't do it for this demonstration. Press Continue and press OK. It will take you to the statistical viewer, and it gives you some important information. For example, it gives you the number of participants. If there are any missing participants, it says 0%, so there's no missing participants. Also standard error, standard deviation, and other outputs that you might need to know. But what we're really interested in is this bit here, the tests of normality. There are two types of tests, but we're interested in the Shapiro-Wilk test as there are under 50 participants. That is the rule of thumb. The significance is here, and this is what we're interested in. Since the significance is over 0.05, this means that the normality is accepted, that is normally distributed. This is where confusion lies, because a lot of people want to know if it's under 0.05, then it's significant. But in this case, if it's over 0.05, that is what you're looking for. You're looking for normality, and it is normally distributed for both height and mass. So we know it's normally distributed, we know it's on an interval/ratio scale, there are two variables, so we know that we want to proceed with the Pearson's R correlational test. To do this, click Analyze, Correlate, Abbreviate by Abbreviate, and you want to move both your variables into the variable view here. Click Pearson's correlation test. You want to make sure it's two-tailed because you don't want any bias in it. This means that you're splitting the alpha score in two directions because you're not 100% sure if it's got to be a negative relationship or a positive relationship. And then you press OK, and you're looking for this table here, the correlations. As you can see, on this matrix, there are two copies of the same thing. This doesn't matter, it's just mass here, or height here, and mass there. So it's exactly the same. And what you're interested in is this significance value here. Since it is under 0.05, you can say that it's statistically significant and there is a correlation between height and mass. Because it's under 0.05, 0.01 and 0.001, you can say that the significance is very high. You can also add a graph if you want to look at this by clicking Graphs, Legacy Dialogues, and Scatter Plots. Simple scatter, define. Move both your variables into either Y or X axis. Press OK. and you get your graph here. Double click it and you can add the line of best fit as well. And there you go. As you can see, height is positively correlated to mass. So in this instance, the higher you are, the more mass you have. So that is how you run a Pearson's R correlational test on SPSS Statistics 20. Thank you for listening.